Hi, welcome back to our course in college algebra. In our last video, we introduced the basic idea of a function. That will be kind of the guiding principle that we will follow in this course, looking at all different types of functions. In this video, we will discuss a special notation that is used to work with these functions. And you'll remember from the last video, when we have a function, we really have three things. We have a set of inputs that we call the domain, we have a set of output values that we call the range, and we have a rule for taking any input value in the domain and finding the output value that is related to that input value. Remember, functions are all about describing relationships. So let me just start and dive right in with an example of this function notation. So mathematicians are not very creative with our names and symbols. Typically when we're talking about a function, we'll call that function f for function. So given this function, let's just do a simple function. We're going to evaluate various output values. Let's find f of 4, f of -5, f of a, and finally f of x plus 2. Okay, so these are the various outputs that we're going to find. Before we do that, I want to spend a little bit of time discussing what this notation means. Okay, so this letter here is the function's name. Typically we'll call it f. If we have to deal with several functions at once, we'll have to name each one a different thing. We might have f, g, and h. The quantity here in parentheses, that represents the input value. And over here, these are the instructions for finding the output value. Okay, so this expression over here, that's your rule for computing the output value. This is a pretty simple rule. It says take whatever your input is, your input x, multiply it by 3, then add 1. So there's 2 steps to finding the output for this function. As we progress through our course, we'll see functions that use different rules and use more steps. But let's start out with this. In fact, something I'd like to do when we're working with function notation is I like to think of the x as just like a blank space. And whatever you put here on the left-hand side automatically pops up in the blank on the right-hand side. Okay? Especially when we start working with variables, folks can get a little confused by the x. So sometimes working with these blanks helps a little bit. So let's evaluate each of these. Okay? So thinking along these lines, if I put a 4 here in the blank, that means I should also put a 4 on the right-hand side. Okay, 3 times 4 is 12, plus 1 is 13. So if we use 4 as the input to our function, we get 13 out. If my input isn't 4, but -5, well, if I put a -5 over here on the left, I got to put a -5 in the blank on the right. So 3 times -5 is -15 plus the 1, looks like we got -14. So input -5 produces an output of -14. The scheme of using blanks actually comes in really handy when we start working with variables. If I put an A on the left, I put an A over on the right in the blanks. So f of A is 3A plus 1. And that's really all I can do with this. So typically, when we're dealing with these functions, if we use a numerical input, we're going to get a number for our output. Number goes in, number comes out. If we use an expression that has variables as the input, then we're going to get something that has variables as the output. Okay, so number goes in, number comes out. Variable goes in, something with variables is going to come out. Let's look at that last one, f of x plus 2. Well, we just follow the scheme. If I put an x plus 2 in the parentheses on the left, and the blank on the left, I got to put an x plus 2 in the blank on the right. So 3 times x plus 2 plus 1. Here I can do a little bit of algebra, I can do a little bit of work there. I can distribute the 3 to both of the terms in the parentheses there. So 3 times x, 3 times 2 would be 6. Now the parentheses are gone, plus the 1, so that one can be simplified to 3x plus 7. Okay, so that's the basics of working with this function notation. Let's look at one more example of function notation. Let's do a slightly more complicated function. So given f of x equals x squared plus 3x minus 2, we're going to evaluate each of these. And I'm going to use the exact same inputs that I did before. F of 4, f of negative 5, f of a, f of x plus 2. So I've got a mix of some numerical inputs and some inputs that have variables. Now remember, when we see this function notation, here's how we're going to think about it. F of blank, f of blank. Well, the rule here says we take whatever input we're given and we square it. And then we add 3 times the original input, and then when all that's done, we subtract 2. So there's more steps to this function. Well, so remember, whatever we put here, whatever is here on the left, also goes here and here. We have 2 blanks to fill in on the right. So whatever we put in on the left, we automatically put in over on the right. Okay, let's think about this. If I put in a 4 in the parentheses on the left, I would put in a 4 in the blanks on the right. 4 squared, we know what that is. That's easy. 4 squared is 16. Right? Remember, squaring means multiplying it times itself, so 4 squared is 4 times 4, 16. 3 times 4 is 12. Now, the exponents, remember your order of operations, the exponent needs to be done first, then the multiplication, then the addition. Okay, so 16, 12, 28. Minus the 2, we get 26. So the input of 4 produces an output of 26. Okay, let's think about what would happen if I put a negative 5 into this function. Now in this first example, I didn't really need the parentheses. Here the parentheses actually help a lot. Okay? We have to take the instructions literally. Negative 5 squared means negative 5 times itself. Negative 5 times negative 5, well, if we multiply 2 negatives, our result is a positive. Negative 5, take that and square it, you get a positive 25. minus 15. So now we're at 10 minus 2, and we get an 8. Let me write it down and do the arithmetic here. We get 8. So negative 5 squared gives us 25. 3 times negative 5 is negative 15. So 25 plus negative 15, which is the same as 25 minus 15, and then minus 2 to get 8. Okay, f of a. Well, if we think about this scheme for understanding function notation, it's very easy to see what's going to happen. If I put an a in the blank on the left, I have to put an a in each of the blanks on the right. A squared plus 3a minus 2. Remember, if we put a variable expression in, we get a variable expression out. Let's do that last one. The input is x plus 2. So if we use x plus 2 in the blank on the left, we put x plus 2's in each of the blanks on the right. Now, let's think about what we get here. Once again, we have to take the instructions literally. X plus 2 squared means we take x plus 2 and we multiply by x plus 2. X plus 2 times itself. Now you have to expand this. A lot of people remember this with the FOIL acronym, first times first, outside times outside, inside times inside, last times last. Okay, so when you do that, you'll see you get x squared plus 4x plus 4. Okay, so that's what this becomes. X squared plus 4x plus 4. Over here, we've got to distribute the 3 to each part. 3x plus 6, and then finally the minus 2 at the end. All right? Now we can do some combining of like terms. X squared plus 7x plus 8. Okay? So once again, remember, if we put in a variable expression to these functions, we expect to get an expression that has variables as the output. That's exactly what we're seeing here. If we put in x plus 2, we get out this expression. Okay? There's one last little wrinkle that I want to tell you about. This scheme of putting in blanks for the input works really well, so I would recommend you use it, especially when you're first starting out with this function notation. But there is one kind of function that can trip people up. So we'll do one more example, clear everything off here. Let's try something like this, and let's make it something different. Given f of x equals minus 7, let's just say. Okay, so this rule is one of those things where it's such a simple rule that people might get tripped up and make it more complicated than it really is. Okay? This rule is saying that the output is negative 7 no matter what the input is. Okay, the output is negative 7 no matter what the input is. Notice the input x doesn't appear on the right hand side. So this is just saying whatever the input is, the output is negative 7. We call this a constant function. Okay, the output doesn't vary. It's the same. It's a constant. So, very easy to compute the outputs in this case. They're all negative 7. So, if the rule on the right-hand side has variables in it, I would highly recommend you replace those variables with blanks. If the rule on the right-hand side does not have variables in it, then you're dealing with a constant function. So don't get tripped up by that, okay? So function notation will be very important in our course because, as we said, the class is all about functions, okay?